felspar mineral from the Itaby quarry. How many elements can it contain? Should we take it home?
So terbium, just like europium, is often used in television screens and various types of displays. And where it comes in is it gives green and yellow colours, which in contrast to the red and blue which europium gives you the full selection that you need to give colour images.
So, Itaby Groover, Itaby Mine. What a great place, the snow's falling. The ASM has designated Itaby Mine a historical landmark for the discovery of 4 periodic elements: yttrium, terbium, erbium and ytterbium. Terbium was eventually discovered, or eventually isolated, by the chemist Mosander in 1843. It was isolated from an earth called Yttria, which was originated in this quarry where we are right now, in Itaby in Sweden. Terbium is a really unusual element. It's a metal, moderate abundance. It's called a rare earth element, which is really quite ironic because it's not as rare as its name would suggest. The abundance is something like 20 to 30 times that of silver, so I don't think it's really rare. It doesn't really have much biological activity, but we do find terbium within the bones in the human body and in animals, but also within the kidneys. So you do find small concentrations, but it doesn't really have a perceived biological activity.
Terbium is also used in certain magnetic devices, and when you include it in certain alloys, it forms magnetic devices which increase or decrease in size depending on the strength or the type of magnetic field which they're placed into, which has various technological applications.
So terbium alloys are really quite interesting because they have what's called magnetostrictive behavior. So what that means is that the size of the crystal or the size of the structure of the alloy itself gets either larger or smaller when it's exposed to a large or strong magnetic field. So there's much research going into the use of these terbium alloys for small motors and small switches perhaps, and also to use as strain gauges and other types of really quite elaborate instruments. So these may well provide us a lot of new research in the areas of nanoscience and nanomachines.
Also, because of its fluorescence nature, it's often used as a marker in biochemistry. So if you want to stain cells and determine whether certain types are present, then you can use it for that too.
So in terms of day-to-day life, where do we find terbium? Well, we find it in unusual devices like energy-saving light bulbs because it stimulates or it increases the yield of light in the mercury discharge that we use to run fluorescent strips. So we find it around us in shops, in houses, in factories, street lighting, everywhere. But what I think is a really quite nice and important application of terbium is the fact that it's used to make phosphorescent materials. So these are materials which generate light or allow us to develop pictures if we irradiate them with something like an X-ray. And in fact, terbium is used to make very, very high light-yielding phosphors for use in screens and visualization screens for X-rays. So what this means is that if I go into the hospital for a diagnostic X-ray, I no longer have to be exposed to long periods of X-rays because the terbium screen allows the generation of the pictures at much, much lower dose of X-ray. So it's really, really quite a significant advance. It's really quite nice chemistry as well.